Really tell us now. Jejeli Jewo. I mean, I've not read my own. Jejeli Jewo. I've not read my own. Jejeli, please. So I ask us to read on translational motion, random motion, oscillatory motion, vibratory motion, relative motion. So when we say a motion is so we have translational motion, random motion, oscillatory motion, relative motion. So when we say a motion is translation, what does it mean? You have an idea, please tell us. Because I asked you to read on it, so it's more like okay, go ahead. I didn't ask you. Go ahead. I want the classroom. Go ahead.
A translational motion involves when the movement of an object when an object move in the same direction or in a straight line, like a car driving on a straight road.
Okay. Okay. If you have a contrary opinion or you have a contrary um or you have an addition of subtraction from what you said, Rocky Adebimpe, this name looks familiar. Okay, Rocky. Maybe we should call you Bimpe or we should call you Rocky.
The, the movement of an object from one location to another.
The movement of an object from one location to another. Where are you located at? Where are you? This call, go ahead, please. This call. Aisha, sorry. Aisha, go ahead.
It is when all parts of an object move in the same distance and the same direction at the same
All
time.
parts of an object move in this. I love the way it started, but there's something else to hear in that dimension right now.
Example, when an elevator is going up and down.
When
A
an
car
elevator
drive
is
a car
going
driving straight road.
okay, Ajayi, Abdullah.
Okay, sir. Is the movement of an object where all points of object undergo the same displacement in the same direction. Example, a train moving on a track.
Okay, excellent. Where are you living? Are you living in where are you living? What state? State.
State
Yes.
or some states.
Osun State. Osun. Okay. All right. Translational motion. Just like you guys have rightfully said. When an object moves in a straight line. So this translational, when we say translational, we can also call it some other names like linear, like linear. So it's not the same thing. You understand? When we say random motion, what do we mean?
Random motion when the motion has no fixed path or direction. The movement will be irregular or unpredictable. Example, when mosquito flying around, movement of gas molecules in air.
Okay. Rotational motion. I want someone else apart from Aisha. Rotational motion.
Behavior that happen without a definite plan, learning entering on a time,
Without what?
without a definite plan,
I'm sorry, say that again. I didn't catch that. Well,
behavior that happen without a definite plan, learning entering on a time,
are you defining random or rotational? Which one?
random.
Random, because it doesn't sound rotational. Sounds more random. That's why I'm asking you defining random or rotational. Okay. Rotation. I want someone to define rotational for me, please.
Rotational motion is the movement of an object in a circular path, in a circular path. Example, a ceiling fan.
Okay. Oscillatory motion. Someone that I've not spoken at all. I told this Laura. Laura Rodia, go ahead, please. Laura Rodia. I told this story. Oscillatory motion.
Vibrating motion is a type of motion where when a object oscillates or moves back and forth about a fixed point.
Okay. Okay. Relative motion. You saw Lawal.
I'm probably fix something. Remember,
Is the movement of a body in relation to another body.
In the movement of an object in relation to another. Okay, very good. You guys have tried. Now let me come to class and explain to you some basic things that JAMB would like to test, and we'll see questions as well. So translational motion is the motion in which all parts of the body, all parts, it is important for you to understand this, and that was exactly the way Ajayi Abdullahi defined it for us. All parts of that body must move the same distance in the same direction at the same time. All parts. So Ajayi Abdullahi gave us the first definition, and he gave us a very good example as well. Example, a train moving in a track, in its track. So that's an example of a translational motion. Example, a car moving along a straight road. If you've traveled very well, in your physics textbook by that Professor Nyankwa, you see there that he wrote Lagos to Enugu is a straight line. I've not been to Enugu before, so I don't know. But there are some few places I know in Nigeria that are straight line. For example, Ilorin to Niger is a straight line. I've not been to Niger before. I've not traveled from Niger to Ilorin before, but I know that acrobats will okay, let's see straight line. I get people. I know that
Lagos to Abuja.
Lagos to Abuja, straight line, are you sure? Lagos to Abuja. It depends where you're going through because Lagos to Abuja, how do you pass? You want to pass Akure. The problem is that you get away from Lagos without talking about the problem. How do you go out of Lagos? Are you passing through Ibadan? That's the problem. So that place, I'm not sure. But if you tell us that um from from um, from down to Osogbo, from there to Osogbo, other places. Now, sorry, guys. So translational motion. Now, it's a bit of confusion that I need to explain to you guys. You check the rolling wheel, rolling wheel. When we see the question, I'll explain. Don't worry. If you don't understand, I have to see the question. So random motion, like you guys said, random motion. When we say body motion is random, it means that the object is moving irregularly, haphazardly, in a disorder form, with no preferred orientation or direction. That's how Yankoa designed it. The is very, very apt. I love it. The irregular facade, irregular disorder, with no preferred orientation or direction, movement or of an object. That's random motion. My voice is cracking. Oh. Is it better now?
Yes, sir.
Okay, thank you. So when we say random motion, that object is moving in an irregular form. Irregular form. A very good example is the movement of air particles. At a particular instant of time, you can't tell us where the smoke particle is going to go. If you know Turari, if you light Turari, or you are trying to burn, or you are cooking, and then or gas, I say gas, or EG. But Turari is even a very good example. If you know Turari, it's called incense. If you burn incense in your house, you will see the way this particle is moving. You'll be moving in an irregular form. You can't even say where it's going to be. Another very good example is when you pollute the yaso and the yaso parain. When you fart, you fart, you might not even be the first person to smell it. I don't want to use the word passive. Let's be English. So passive has nothing to do with the nose. It has nothing to do with nose. Passive. When you get to English I'm going to explain to you. But passive, this word passive, it has nothing to do with nose. You can't perceive the smell. You can only perceive changes. For example, if you think 2018, 2019, 2016, 20, you will know that that area is not the same again now. You perceive some changes. Your molar that man is so excellent. I'm not complaining for him, but he actually did justice. If you read further, you will know that he did some very good things. You'll be able to perceive. That's what we perceive change. We do not perceive with our nose. If you take the dictionary for the meaning of the word perceive, it has nothing to do with what nose. So don't go after and say I can perceive the smell. You just shot yourself in the leg. You can smell. So the register for everything that has to do with smelling. We have what we call fragrance. We have smell. We have odor. We have aroma. We have stench. We have what else? Oh, I've forgotten buku. So fragrance is pleasant to the nose. When you smell it, you would appreciate it. Smell can either be good or bad smell. So when you fart now, that one is bad smell. I mean, when you got the I see 1,000 by my yellow, not possible. Now you that it's not possible. So odor, when you use the word odor can also be bad or good. But most times it's always negative. You have to understand the concept of negative and positive words. So words are negative. Odor, bad odor, body odor. Aroma has to do with food. Aroma, it has to do with food. Then I'm a put stench. Only on. For example, when you put in the toilet for years or months without washing, not stench. So stench is offensive odor, offensive smell. You understand? Okay, that's my good. So when you fart, You by the fact, you might not be the first person to smell it. It might be someone that is like 10 or 5 meters from you. Hmm, hmm. Let me tell you one trick about smell, about fat. The first person to say most of the time, that's the first person. That's the person. That's the person that makes. I'm telling you, and people that are smiling, you can see they have the experience. They are the one. Just know them. If you smell anything in this class, it's those people that are smiling. So when you smell it, when you smell that pollute or that fat, so the movement of that odor, that smell, the movement is also what? It's random. You can't predict the next person. That's why you see some people, they'll be acting innocent. Those people that say, take that one, go, we will give you, we will give you. It's because they don't know where it's going to go. They don't know. Nobody knows. Do you understand? So that movement is also what? It's also random. Another very good example of random motion is Brownian motion. Brownian motion. You do this in biology and I think chemistry. Diffusion, Brownian motion. Another very good example is drunkard walk. Drunkard walk. If you have seen a drunk person before, they don't know if they want to go forward or go back. They don't know if they want to go to the right or go to the left. So they just sit there and they end up in a gutter. So drunkard walk. Example of random motion, the movement of beat. It is irregular. You can't predict the exact place it's going to be in the next minute. Just vroom, just now, vroom, just going. With no preferred orientation or direction. Now, there's a confusion between random motion and oscillatory motion. Because of that confusion, I will quickly come to oscillatory motion. When we say oscillatory motion, it's a motion, it is the to and fro movement of an object. And this motion, we say it is periodic. When we say something is periodic, it means it is going to and fro, to and fro, to and fro. And the motion is always what? Repetitive. It is repetitive in nature. So you see that the object keeps repeating itself, repeating the motion to and fro, pacing around. When someone is pacing, the person is just going and coming, going and why are you pacing around? Going and coming, going, you understand? So if you have seen a rocking chair before or a rocking horse before, now it looks like this. People are had a very interesting childhood. You would not rocking chair, but you are from Ede. I'm sorry. I'm not saying your child is not interesting, but it's actually very boring. I'm not saying it's not interesting. So that rocking chair is something like this. You don't sit down on it and you rock it. It's going back and forth, back and forth, back and forth. You are surprised. You don't even have KFC. Common KFC you don't have. Let me talk. So you sit on the rocking chair, you rock it back and forth. That's an example of concentration. Another example is um Anguilla. That's what the Yorubas call it. It's called I don't know what it's called. Pendulum. It's a wall clock that has a ball in it. My network is very uncoming. Okay, can you hear me now? Okay, good. So let's quickly look at the picture of one of the beauty of online class. You can quickly look at the picture of mm, pendulum clock. Now, can you see it? Most of you have seen it before. It's not very common anymore. Look at it here. So it makes that bang, bang, bang. It's not this cat here. It's called Aguelepon. That's what Yorubas call it. So if you check this video, you just see it going and coming, going and coming. So you can see the way it's going and coming, going and coming. So that's what we call oscillatory. So when something goes and comes, goes and comes, goes and comes, we'll still look at some more examples as some very reasonable examples that you'll be expecting to see as we go ahead with the questions. But I don't want to say some things now because I want you guys to have a feel of it. So oscillatory is always to and fro, like I said, and the examples I've given, I gave you rocking chair, the spin of a talking drum. You know a talking drum? Spin of a talking drum. The Yorubas call talking drum, they call it gongon. You know, they use that drum to talk, to tell you to listen to any answer. And they can say, din, 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 din. So it means something. They can say it means, Aisha, you are going to Umrah next day. You can do like that. And say, give me, give me, give me, give me, give me. So it means anything. You understand? So skin of a talking drum. So that's skin, the skin of a talking drum. Once you beat it, it vibrates. And it comes to rest. Now, the difference between random and oscillatory that DAM would want to test you with is this. Oscillatory motion, it has a fixed mean position. Don't forget. Oscillatory, it has what? A fixed mean position. We know the highest point. We know its rest point. And we know the other highest point. Do you understand? But random motion has no mean position. Do you get it? It has what? No mean position. Do you get it? This too is very important. Now, rotational motion, like you guys said, I think it was Atia that gave us that definition. Rotational motion is the motion in which a body turns about a fixed axis, a point that is fixed. From that point, it now turns around that point. This is the difference between rotational and circular motion. They are different. Don't divide rotational motion as a circular kinekan. Don't put it in your definition line. Don't do it. Rotational motion is the motion in which a body turns about a fixed axis. Circular motion is a topic that we treat, just like we treat linear motion. We treat it separately and we discuss about some things. In circular motion, we have angular kinetic, we have angular speed, angular velocity, kinetic, we have those things. Centripetal force, centrifugal, all those jargons, we have it there. But under rotational motion, it is what the movement of an object around a fixed point. You get it? It turns about a fixed point. Example is ceiling fan. You can see ceiling fan here only because it's okay. That's the fixed point. It is now rotating around that fixed point. You get it? You get it? It's not the body itself going around an object. You get it? So that's circular motion. Another example, I've seen this question in WAEC before. They ask you to give a real life, that's the interpretation of the question. It's not like the way I'm saying it directly. They ask us to give a real life scenario of a circular motion, a rotational motion. So I now checked some options and I saw the movement, the way the moon orbits the earth, the way the earth orbits the moon is one. Just the example, that's also rotational motion because it's orbiting around a fixed point. Yeah. Yeah. So spinning top, earth rotating about its axis and all of that. Now, there's a question that Jump is going to ask you. They will ask you that when they roll a rolling tire is not only rotational, it is the combination of rotational and translational. Do you understand? So Jump will ask you that about a rolling tire. When we see the question you understand, I'm going to process more of the point. Mm-hmm. So don't forget, rotational and circular motion are different. Mm-hmm. Very important. Rotation requires a fixed axis within the body, while circular, no axis is needed. Oscillatory motion, we can explain that one now. So now let's talk about relative motion. Just like Yusra said, who else cannot hear me? Is it only Aisha? If it is only Aisha, it means that Aisha's network is not good. Rakib, can you hear me? No, no, wow. Network. Aisha can hear me. Aisha can hear me. Aisha can you hear me clearly, loud and clear. Or is it cracking? People can hear me now. Okay, I think network is good. Aisha, can you hear me now? Oh, Aisha, maybe you should leave and join in. Please. Someone should type in the chat that should leave and join in. Please. So relative motion is okay. If you can hear me now, is the motion measured with respect to another object. The motion of an object measured with respect to another object. Two objects now. We are now measuring the motion of one with respect to the other one. Do you understand? Now, let's take two key points now. If a passenger, person A, is sitting in a bus, this person is at rest relative to the bus. My voice is cracking. How is it now? Can't we just how? How is it? How is it? Is it better now? Can you can really clear, let me know. Like I know it's my own network or it's Aisha's network. It seems people cannot hear me. Okay. Let's do this. Let's do this. Mm. Can you hear me clearly now? Can you hear me clearly now? No. How is it now, guys? Is it better now? Better now. Aisha, can you hear me? Is it better now? Is it better now? Is it better now? Alhamdulillah. So, if the body of an object is in a box, if the object is inside a box, that object is at rest relative to the box. If I am inside the box, inside that box, I am at rest. That's why I can keep going. I can walk through the box. I can walk inside the box without falling. But immediately the driver presses his brake. What happens? What happens? I'm going to tilt forward as if I want to fall down. That's because the speed that the car has before is still inside me. So it's still as if I want to go forward. You understand? So when I am inside it, and that also explains inertia to tell us that when an object is in motion, it does not want to stop moving. Now, when you sit inside a bus, the bus just starts moving. What happens? You go back. Is that it? Because you also do not want to continue with that bus. But once you start moving in that bus, you cannot decide to go back. It's not possible. Do you understand? So I'm going to explain some things around this when we see some questions as well. So just know that if an object A is sitting inside a bus, it is at rest relative to the bus. But it is in motion relative to the road. Is this clear? You can see the difference. Relative to the bus, the body is at rest. Relative to the road, the body is what? In motion. Is that clear? Because we are leaving those roads. But the bus, are we leaving the bus? No, we are still inside the bus. So we treat object inside the bus as if it is not working. If we are discussing about the bus, but if we are discussing outside the bus, the object is in motion. Is that clear? Good. So anytime you see a question, always ask relative to what? Is that clear? Always ask this question relative to under relative motion. You see questions and you enjoy it. No worry. Now, we do addition and subtraction in relative motion. So let's quickly come to questions here and let's look at what is going on. So I've discussed a lot about these guys, and I don't want to talk more than that. So when we see questions, I'll just explain and we'll continue from there. Now, question 1. The motion of the moving skin of a talking drum. I've even said this today. The motion of the moving skin of a talking drum. The moving skin of a talking drum. What's the motion? It is oscillatory. Ìwọ tó bá ti lu tó bá ti tẹ̀lé àwọn àfáà tó máa ń gbowó lóde tẹ máa ń lu bàǹdírí. When you beat that skin, it's just as if you are plucking a guitar also. If you plug a guitar, about guitar, you see the spring going. and it comes to rest. That's the exact same way. When you beat if you beat what's it called, a gate in a very silent place, you hear that sound and it's going to come to rest. Number one, it has to do with echo. Number two, it also has to do with vibration of the particles. Do you understand? So that's the vibration. Then it comes to rest. So that's oscillatory vibration. Do you understand? So the motion of the moving skin of a talking drum can be rightly described as what? As what? Oscillatory, thank you. Or vibratory. So both are correct. Either oscillatory or vibratory. So question one, the option is D. Two, which of the following types of motion are oscillatory? Now, we are going to talk about oscillatory motion here. Now, a diving board, when used by a diver. Let's come here and quickly look at what a diving board is. What's a diving board? Who has seen? Okay, let's come here. I also we see a picture of somebody that will not open his hour because most times it's always our diving board, diving board, diving water. Yeah. Diver with a diving board, diver water with a board, with a board. If you did not see this one, if you did not see it, you might not want to agree with me. No. Diving board. Let me type first diving board. Diving board. See what I'm saying? So this arrow inclined. Let's do this one. What are they called? Okay, let's check ski diving. Okay, let's come back here. Okay, so a diving board, when used by a diver, when the person taps the board, let's come back here. I want to find a very decent picture for Washoe. Let's manage this one. Now look at the board is shaking, right? Can you see? So once it taps the board, what happens? It's going to yeah, sure. No, I don't want the one that's straight. Let's manage this one. Sorry. Now look at the board. Can you see? Look at the board. What's the motion? Can you see that it's still shaking? Look at the board. Going up, down, up, down. That's what I want to see. The board. Can you see the board shaking? So what kind of motion is that? What kind of motion is that?
Oscillatory.
Oscillatory. I try to find the one that's the arrow is now open. Okay. A diving board, when used by a diver, is oscillatory motion. The motion of the balance wheel of a wristwatch. Balance wheel of a wristwatch. Now, we have different types of wristwatch, but we are not talking about smartwatch because now everybody has smartwatch, and this smartwatch is not even. If you are like me, when I was in secondary school, when I read, if I am doing calculation, anything calculation, in fact, you can carry home theater and place it beside me. I will not be distracted because it's calculation. But if I'm studying, like I need to read something, maybe chemistry, biology, or I want to understand some physics concept that are theoretical, I can't assimilate where there's noise. In fact, in the middle of the night, I'll go and remove, it is always very silent. I'll go and remove our wall clock because it used to make one noise. It goes. Who has experienced that before? So that noise affects my assimilation. So I have to go and remove the battery. If you have a wristwatch, all those wristwatches are not smartwatch, and it is not analog, it's not analog watch, digital, and not digital, sorry, analog. If you open it, if you used to change your battery by yourself, you will see that at the back, there's something that is always going. No, we don't even need to stress ourselves. Let's take video now. Even if you have a wristwatch now, remove it. Not digital wristwatch, not Oraimo, and remove it and place it at the back of your head, and you will hear a sound. Tick, 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 tick. Balance wheel of a wristwatch. You see the video. So it's always in oscillatory motion. Can you see? Can you see it? Can you see? Going. That's what we are looking for exactly. So that's the balance wheel of a wristwatch. If you place it at the back of your head, you will hear that sound. Tick, 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 tick. So what kind of motion is this, guys? Flying, oscillatory. So oscillatory. The motion of the turntable of a record player. If you know Walkman, I don't even believe you. I don't think you guys will know Walkman. But let's go to YouTube and check turntable of a record player. But there's something called Walkman. Okay, let's just come to Chrome. Turntable of a record player. Or maybe we have DJ in the house. Turntable for DJ. So can you see this thing that they do? Tick, 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 tick. Is your halal DJ here? DJ Yusha? Call me for your wedding and your naming ceremony. DJ Yusha, DJ Aisha. Tick, 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 tick. That thing that they shake. So that's called what? A turntable of a record player. And you can see the way this guy is trying to tune it. It's not oscillatory, it is what? Rotational. You can say I said rotational. So that's turntable of a record player. So this one is what? The motion of the center of a 10 kobo piece. Fortunately, unfortunately, you guys have not even seen 10 kobo before. Who has seen 10 kobo here? I've seen 10 kobo. 10 kobo. Aisha, are you sure? Rahima, are you sure? 10 kobo. Okay. Okay, you have seen 10 kobo before. Have you spent 10 kobo before? Okay. So the motion of the center of a 10 kobo piece as it rolls down an inclined plane. An inclined plane is a plane like something like this. You now put a coin, you now roll it down. That center is rotational. It's going to rotate. The motion of the needle of a DC ammeter into which a low AC current is passed. Now, you guys know what a stabilizer is. You guys know stabilizer. I know stabilizer. Raise your hand. I don't know stabilizer. Raise your hand. Now, now, sorry. For option 4, option 5, sorry. So it says the motion of the needle of a DC ammeter into which a low AC current is passed. Now, if you've seen a stabilizer before, what happens to it when light enters into it? What happens? You don't even know what I'm saying. You don't say, in a stabilizer, there's something like this, a component like this that has 1, 2, 3, 4. It now has. You just observe that the arrow is going to go boom. Abi, that arrow that moves. That's what they are talking about. Now, the motion of the needle of a DC ammeter into which a low AC current is passed. Now, this needle undergoes oscillatory. So this option here is also oscillatory. Now, the AC circuit, when we say AC, it is called alternating current. DC means direct current. We'll explain that when we get to it. It changes direction continuously. This AC current, the alternating current. And at low frequency, the current reverses slowly. So what you are going to see is that you are going to see it deflect to the right. Vroom. It's going to return. Vroom. Right. Vroom. Because it's what? It is a low AC current that is going inside it. If you have stabilizer in your house, that you connect all the load in your house inside it. Tó bá múná tó bá low, kí ló máa ṣẹlẹ̀? A máa dún kán, 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 kán. That's exactly what they are asking. So the correct answer is option I, and B. The motion of the needle of a DC ammeter into which a low AC current is passed. If high AC current pass through the DC ammeter, the AC is going to reverse that current very, very fast. Now you don't even notice it. You actually want to stabilize by turn on, you don't even notice it. Do you understand? So it's as if it is at what? At zero. So no observable motion is what is observed. So the correct answer is D. I have seen past question, pick option A. In fact, this question, if you tell Dan Bremix, that guy chose option A, 1 and 2 only. So if you like, you can sit down with Dan Bremix and say you want to study everything there. The guy actually did very good job. Very good job. Samuel Adedara, he did a very good job. Very, very good job. This thing he did, this Dan Bremix person, I've been thinking of doing something like this before, but He did it. So very good job. When a ball rolls on a smooth, level ground, the motion of its center is when a ball rolls on a smooth, level ground. Type your options, please. Options. You can see the options there. Just pick your answer. I can see cluster of translational and rotational. In fact, I think what we can see is not cluster. I can only see. I think I can see more of rotational. Only Al-Bashiri picked translational. Okay, Al-Bashiri, please tell us why do you think it's translational? Somebody typed something. I'm just saying it. So I thought oscillatory has lower frequency compared to vibratory. When is this? 15 minutes ago. I didn't see it. I didn't see this to Rahima. I thought oscillatory has lower frequency compared to vibratory. Oscillatory motion and vibratory motion are the same thing. Lower frequency. Okay, Al-Bashiri, please can you explain to us why do you think it's translational?
I picked translational because they said when a ball rolls on a smooth level ground. And translational, you said translational is a straight line. It's the movement of an object on a straight line. So smooth level ground. That means that level ground will be very smooth. So it will be straight. That's why I picked translation.
Sorry, Al-Bashiri, are you a male or a female?
I'm a male.
Oh, mashallah. Okay. Okay. Who else wants to pick translational? The answer is translational. Now,
Rotational.
when a ball rolls on a smooth level ground, the motion of its center is translational, but the explanation Al-Bashiri gave is not the reason why it's translational. Now, the question says when a ball rolls on a smooth level ground, the motion of its center. Now, when you have a ball, I told you, when something is rolling, I said it, but I didn't go deep with it. I said something rolling tire here. I said the rolling tire has two types of motion. Now, when an object is rolling, it has two types of motion. The motion around this fixed point. You know, I told you that rotational motion is when an object moves around its own axis at a fixed center. You see, at that fixed point, for a fan now, let's look at the fan. When we say a fan is rotational, Abi, it is not the center and it's rotational. You know, the center is fixed. What is rotating? It is the axis. Abi? So at the center, if it is now moving, if everything is moving, at the center, what you have is translational. I will explain. At the axis, what you have is what? Rotational. Now look at it. Look at it now. Agba bọ́ọ̀lù lẹ́lẹ̀. Center yẹn, ó kọ́ra mi center yẹn kàn move lọ báyìí. It is the axis that is rotating. The center is, you can see that straight line. It's not changing. Do you get it? That is not clear. Abi? Can you only hear me? Very good. I have a straight line like this. We now play the ball. This center here, is this center rotating? It's not rotating. I play the ball, Mogba parallel, you know parallel. Female, sorry. We play a ball that is not, we play the ball and we make sure that the ball goes down like this. If you are playing ball as a girl, you know parallel now. You don't know parallel. And the Mogba parallel for. Oh God. Parallel shot means that you make sure that the ball did not go up. It goes through this point. Abi? Guys, what is rotating? It's not the center. What is rotating, guys? It is the axis. It rotates. So that rotation that is going like this, the center is still remaining as if the center is going in a straight line. Can you see? The center here is still the center here. It's not rotating. The center is, in fact, it is uniform translational. Do you understand? So that center is not rotating. The axis is what is rotating. So when an object experiences when an object is moving, when a rotational object is moving in a straight line, you are rolling it. That center is what translational. Do you understand? The center is what translational, but the axis is what rotational. Do you understand? Is it clear? Are you sure? Is it clear, or should I explain again? Should I explain again? It's not difficult. Just need to understand my own explanation. Is that clear? Good. So this question here now, if you have picked rotational, you now come back to tell me that for question here, I smashed it. Not only that the question smashed you. So when a ball rolls on a smooth, you can see smooth level ground, the motion of its center is translational. But the axis, if the thing is going to axis, you can see totally different answer. What's the answer? Rotational. Is that clear? Good. If you check again, if you check Jam Remix, I am sure that guy is going to pick rotational as the answer to question 3. I am so certain. Going to pick rotational. Question 3. This question here is 1985 question 4. No, 1995 question 5. Let me check. I know, 1995. He picked rotation. I'm not saying that I know all the answer to all the physics questions. So no, that's not what I'm saying. You understand? That's not what I'm saying. So the motion of smoke particles from a chimney is typical of, I don't know if that's the correct pronunciation. I'm not an English teacher, please. It can be chimney or chimney. Have you seen a chimney before? let me show you. That's the beauty of doing online class. You can quickly check and see it so that nobody is going to use something to bobo you. Chimney. That's the comprehension here. Can you see this thing? Before they used to build like this so that they have a place whereby like they have this thing in the house. They used to have people in the house. You watch this Home Alone. They had people in the house. They used to have people in the house because it's always very cold. Winter and long. But we don't need it here. We don't have people and see no we can say it here. So that smoke that is coming out of it, what is the motion of that smoke? Because oscillatory. That one is very straight. Very simple. Oscillatory. Sorry, oh. It's random, oh. Thank you. I almost picked oscillatory. It's random. Now, which type of motion do the wheels of a moving car undergo? Can you see now? Wheels of a moving car. Wheel is the tire. Wheel, tire end. So, motion would. Can you see? Random and translational. Rotational and oscillatory. Translational and rotational. Vibratory and translational. See? The axis is rotational. The center is what? Tó bá jẹ́ pé táyà mọ́tò center ò kìí ṣe translational ni. Ó yẹ kí táyà yẹn máa yọ kúrò mẹ́rin. That center is fixed. It is just going straight. Ó kàn lọ ni. Axis ló ṣe kí ni o? Ló yí about the center. The center is moving straight, translational. Do you get it? During a football training session, two players repeatedly passed the ball to and fro between them. Which of the following describes the motion of the ball? Simple harmonic motion. The acceleration of the ball is not directly proportional to the speed of the ball. The acceleration of the ball is directed towards the fixed point. The equivalent position of the no, what's all this diagrams? Okay, read the option and tell me what you think your answer is. 6. So what's our answer? During a football training session, two players repeatedly pass the ball to and fro between them. Which of the following describes the motion of the ball? If jam decide to kill you, they will kill you. They decide to help you, they will help you. There was 1 year like that, people scored 300 in jam. I had some students who wrote that jam and they tell me that jam here was simple. Yeah. That's to tell you their level of preparation, what it prepare. For them to say that jam here was very simple. So what is simple harmonic motion? Someone says C. C. Now, the question says, during a football training session, two players repeatedly passed the ball to and fro between them. Now, this to and fro here, it gives us a signal of what? Of oscillatory motion, right? Or vibratory motion. If in your mind, you've already registered it that simple harmonic motion is vibratory motion or oscillatory motion, okay, the question is, because not all simple harmonic motion are oscillatory. Is that correct? Not all the to and fro are simple harmonic. So A is out of it. Is that correct? For a motion to be simple harmonic, two conditions must be satisfied. Condition number one, acceleration must be directly proportional to displacement. I will explain when we get simple harmonic motion. Or condition number two, acceleration is directed towards the what? Towards the mean position. Now, if the ball is kicked by a player, ẹnìkan ló gbá bọ́ọ̀lù yẹn. Person number A, force tó máa fi gbá, the person can, player A and player B. Player A can use a more force compared to player B. So we can predict that the acceleration is directly proportional to the what? To the displacement. We can't predict that. And the acceleration is not proportional to displacement. We can't conclude and say that. Do you understand? So that's out of it. Option B, it says the acceleration of the ball is not directly proportional to the displacement of the ball. If what I said now, you understand it, you know that option B is the correct answer. I said acceleration is directly proportional under simple harmonic motion, and that's the reason why we are not picking this for simple harmonic motion. Now, saying that acceleration of the ball is directly proportional to the displacement means that time to ever by also play during a football training session, two players repeatedly pass the ball. We are not sure that A draws by two of the training here, B draws by B to the side also came by B log by A to the side by A can run here and pass to B. So the displacement or the direction varies. It's not directly proportional. That is the correct answer. The acceleration of the ball is not directly proportional to the displacement of the ball. Do you get it? See, the acceleration of the ball is directed towards a fixed point. That can be, but it's not all true for all cases. It's one condition for simple harmonic. But what of the other hand? Do you understand? So it is best that we choose option B. That option C, it has so many reasons why I will say it is not correct. So the acceleration of the ball is directed towards the fixed point. No. How are you sure that it's directed towards the fixed point? Fixed point means that this point, when B ran here and passed to A, is that a fixed point? No, it's not a fixed point. Do you understand? The equilibrium position is the center of the distance between the players. This is just an option that you need to read. Once you pick the option, you are good to go. Is that correct? So this one here is calculation, and we've not talked about calculation yet. Let's quickly come to relative motion and talk about relative motion quickly. So we have just 3 questions on relative motion. 1992, 2010, 2021. A boy sits in a train moving with uniform speed. You can see that we spend a lot of time explaining just this question. You can see how we took our time. And that's what I was telling you guys about calculation. I love calculation so much. So much. Theory questions, I don't like it in like theoretical questions where you have to rack your brain. It is rack your brain, or it's not crack your brain. Rack your brain, not crack. You can't crack your brain when it's not or not. That's salah. Or you can't crack it, you rack it. So a boy sits in a train moving with uniform speed. This thing is important. And I will explain a lot when we get to speed. I said I was going to explain about some guys. These guys, I'm going to explain some very important things about them that will help you as we navigate through. A boy sits in a train moving with uniform speed. The boy is inside the train, and the train is moving on a straight track. If from his outstretched palm, he gently tosses a coin vertically upwards, the coin will fall A in front, B behind, C beside, D into. Type your answers, please. I'm waiting for your answer, though. I want you to pick. Who picks card from? It's A. Very good. A. I can see C. I can see A. I can see. Oh, into is spam. Into is spam is not an option. Oh. Okay, into is spam. B. 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 A. Okay, no. This part is B. C. D. A. C. A. C. Now, you understand this question when you think of it in this form. A boy sits in a train, and that train is moving with uniform speed. It means that when we say something is uniform, what I want you to know is that anything that is inside that thing, it is as if that thing is not moving. Is that clear? It is as if that thing is what? Not moving. A boy sits in a train moving with uniform speed on a straight track. Because it is uniform, it is as if it's what? Stationary. I said it here. If an object A is sitting in a bus, at relative to the bus, it is as if it's what? At rest. I said it now. At rest relative to the bus. At rest, in motion relative to the road. Now, it says, if from his outstretched palm. Now, the boy now moves his hand. Oh no, where's Iwaju? Two things can come to your mind. You might be thinking that, oh no, where's Iwaju? Nino train. Or oh no, what's it? Oh no, where's it? Nino train. You can say it's two different things now. That one, oh no, where's it? Iwolulu is not part of the question. So erase it. It says, from his outstretched palm in the train. Where is the boy in the train? Is he going to put his arm outside and it's inside the train? No. It's going to be inside the train and his hand is going to be inside the train. So inside that train, from his outstretched palm, he gently tosses a coin vertically upwards. Oh, one nowhere so síwájú báyìí, oh nowhere in the train, oh nowhere síwájú. Oh, what the coins okay. The boy, it's inside the train. And I told you that the train is what? Uniform, which means that it is what? Not moving. That point itself is also inside the uniform train. It means that that coin is also what? As if it's not moving. Both the coin and the boy, it's as if they are not moving. If you are standing and you throw a coin up, all things being equal, the coin is supposed to fall down in your palm. So the correct answer is what? Into his palm. Not in front, not behind, not beside. Any question? Any koyemi? Any oyemi? Thank you. Another question that I will ask you, if you tell me that it is in front, what if it threw the coin backward? What do you coin saying? The question where you coin. Do you understand? So if from his outstretched palm, or what not coins one loaded to coin is okay now. It's as if the boy is not moving. Because we are looking at the motion of the boy relative to the train. Do you get it? Rocky, you have a question? Okay. Two cars moving in the same direction. There's something I wanted to say here. When we want to do, sometimes we do addition and subtraction of some things. When they are moving in the same direction, we subtract. We subtract their speed. When they are moving in opposite direction, same direction, subtract, opposite direction, you add. Is that clear? Now, that's what you are going to use to answer question 2 and I think question 3. Two cars moving in the same direction, have speed, this and this. What is the velocity of the faster cars measured by the observer? Just subtract 100 minus 130. The answer is 30 kilometers. That's the answer. No wahala. So very simple. So but money. Two cars A and B are traveling at this and this at opposite direction, respectively. The relative velocity of just add 60 plus 90 kilo for 150 kilometer option A. It's better. So thank you so much. Thank you. Now, Ibiawila Day, you have now gotten to the real work. What we have been doing since is just play, and I can tell you that it's just play. It's just play. Now, when we say speed, let's start with distance. Distance is the interval between 2 points in space. Interval tó wà láàrin nǹkan méjì. It is length. Length náà ni. But tó bá jẹ́ pé when we are talking about motion, we don't like to call it length. We don't like to call it length at all. In fact, if you call it length, we can penalize you for calling it length. So we don't like to call it length. We like to call it distance. Is that correct? We like to call it distance. We can also call it height also. And depending on the case, because this motion that we want to talk about, I'll quickly cram 3 types of motion together. The first one is called linear motion or rectilinear motion. We have vertical motion. We have motion at an angle. And we have projectile motion. 4. We'll cram them together. We'll do it like one. When we say linear motion, we are talking about a motion like this. On a straight line like this. When we say vertical motion, we are talking about motion like this or motion like this. Up and down. For linear or rectilinear, we're talking about motion going from right to left or left to right. Vertical motion, we're talking about motion going up or down. Motion at an angle, we are talking about motion that is not going up and is not going down, and it's not going to the left, it's not going to the right, but it is going at a particular angle. Angle. For example, about taufa. It is almost similar to projectile, but I like to always treat it separately. I like to do it separately. Do you understand? So when we are talking about distance with respect to linear motion, we represent it as S. When we are talking about distance with respect to vertical motion, we represent it as H. Can you see the difference? Can we see the difference? Good. That is distance. The symbol is meter. Meter and the symbol. Don't forget. Don't stress yourself. This thing is just code lasani. Code lasani. Magina ni not chicken. Magina ni star. Àwọn akọ́kọ̀ like ká máa lo not chicken ni. Àwọn kan like ká máa lo star. Àwọn kan like ká máa lo join. Àwọn kan like ká máa lo bedan. Is there still bedan? Ṣé bedan ṣì wà? Oh, you don't even know what bedan is. And some people don't even use Maggi. They say Maggi is not good. They don't use Maggi. They use alubosa. And some other things like that. They say Maggi will kill you. Use Maggi, you're going to die. See, Maggi is molecule amount. I'm not saying that you should use Maggi or not use Maggi. But you say that I'm not a nutritionist. I just eat food that is sweet. Now, So we can use distance S, sometimes we use distance D, sometimes we use distance H. It is distance. Do you understand? Maggie, they're down, and just Maggie. Now we have displacement. Displacement. Displacement is not really important here. It's not really important. So I will not talk much on it, other than what you know before, that displacement is what vector, while distance is what scalar. Now let's go to speed and velocity. Speed is the ratio of distance to time. So that formula that you know, that S is equals to D over T, that's this formula. Speed is equal to distance over time. So distance here is D, speed is S, and time remains T. So the formula for speed is distance over time. And the unit is what? Meter per second, because distance is M, time is second. So you can write it as this, M per S, or ms minus 1. Velocity also, that's the same thing you need to know about velocity. The same thing, just that it is displacement over time. It has the same unit as what? As speed. We've talked a lot about all these guys in quantities and all of that. Another very important thing that you need to know, very, very important, is that they can give you conversion. JAMB is very, they know that these questions are simple for you. They now disturb you with conversion. So they can give you kilometer per hour, and you have to change it to what? Meter per second. That's what we use. So if you have, for example, you have 72 kilometers per hour, you can't use it like this. So, and you are seeing your options in meters per second, or meter, or seconds. You have to convert. You have to take 72 from kilometer to meter first. How do you do it? 72 times 1,000. Kilo means 1,000. So if one place is 8 kilometers, in meter it is 8,000 meters. In the engine from Akure to Kano is 800 kilometers. 800 sharp. So 16 hours, 12 hours, 18 hours, depending on the kind of car you follow. Might be lucky 12 hours, sometimes you might see 15 hours if there's no odor. I like to travel. So 800 kilometers, if you don't take it to meters, what it will be? It will be 800, then 1, 2, 3. 800,000 meters. Very, very long. Have it? Now, after you've converted from kilometer to meter, you have to take the hour to seconds. So you have to move from hour to minute first, then minute to seconds. That's 60 seconds, make 1 minute. 50 minutes, make 1 hour. 24 days, make 1 year. All those diagrams we used to read in secondary school. Or primary school, it will help you now. Because to move from hour to minute is 60. Then from minute to second is another 60. So you have to do 60 times 60. So if you do this conversion, 72,000 divided by what? 3,600. That will give you what? 20, 36 and 720. That should be 20 meters per second. You get it? So because of this part, that's why you are dividing by 60 by 60. One student has once asked me that 70 kilometers per hour is big now. And it's supposed to be more than 20 meters per second. Why do we have it less? So you can think about it and tell me your answer later. Now, that's about speed and velocity. We have different types of speed. We have uniform speed. And as we see questions on that also, I will explain some things about those things to you. Any other thing I forgot, I will explain to you. Now, we have acceleration. Acceleration is change in velocity over time. Change in velocity over time taken to make that change. So acceleration is, so when we say change in velocity, in physics, when we say change in something, note it now. It means we have the initial of that thing and we have the final. So to get that change, we have to remove initial from final. So we can say acceleration is what? Our change in velocity now. That's the symbol for change. Triangle. Change in velocity is what? Final velocity minus initial velocity. Final velocity is the velocity that you use to get to where you are going. V. Initial velocity, the velocity you started with, U. So acceleration is going to be V minus U over T. This is the formula for acceleration. It is this formula that metamorphosized into V is equals to U plus AT. And also S is equals to UT plus half AT squared. And also V squared is equals to U squared plus 2AS. And S is equals to 1 over 2 U plus V then T. Now, these four formulas are for rectilinear, linear motion. We are going from what? From left to right. Formula number 1, formula number 2, formula number 3, formula number 4. There's another formula that you need to add to it. S equals to D over T. It is the man save life. Now, this S here is different from this S here. The black S is different from the red S. The black S is speed. The remaining S up here is distance, like I told you guys before. So acceleration is the rate at which our velocity is increasing. We know that Usain Bolt is the fastest man on the earth. And at the last time I checked, and I don't know the current fastest man, it can be anybody. So when we talk about acceleration, the unit is meters per second square. Once you see meters per second, don't stress yourself. The acceleration they are talking about, it's nothing. Do you understand? Now, there are a couple of things that we need to know about this topic. Number 1, when a body starts from rest, when you hear the word a body starts from rest, don't stress yourself. Our initial velocity U is equals to 0. When they tell you that a body starts from rest, it means that it has no speed. Speed is 0 in speed here. For example, on your track, get set, then before you start that motion, your body was at rest. Speed is 0. Number 2, when a body comes to rest, or when a body stops, when a body comes to rest, or when the body stops, nígbà tá a ti pa engine mọ́tò, when speed here, the body is not moving again. So the final velocity in that case is what? 0. Is that clear? Point number 3. The time it takes for an object to move, to travel, let's use travel, to travel from point A to B is the same time it will take to move from B to A. If it takes you 5 seconds to go from A to B, but don't go along from B to A to take you 5 seconds also. Once we know the time to go, we already know the time to come back. Do you get it? Good. Now we now start to solve questions, and there are some questions that I'm sure that you guys might not have seen before. I am so certain, but there are some questions that you guys will not have seen before. Is that correct? We spent extra 7 minutes. I think it is sufficient for a lesson. We will stop here today. We'll continue from here in the next class. Please make sure you go over the recordings. We'll try to provide the recordings as fast as we can, and we'll update you once the recordings are ready. Thank you so much, guys, for your time. I really appreciate your consistency, and English is not coming. All right, thank you, sir.